All right. So we are taking a look at page 50, and the goal of this is that we can understand. So we're going to be taking a look at minerals, and the minerals are going to help us understand about the Earth. Because second quarter, we're going to spend a lot of time learning about what's going on with the Earth. Why does it look the way it does? Why are the things on the Earth happening the way they are? And so we need to kind of start from the more simple things and building up to more complex things. Jenna?
Is there any way to prove that the Earth isn't flat?
Is there any way to prove that the Earth isn't flat? Yes.
There's no way to prove
We
it.
have people that are literally going up into space and looking
I know.
back at the Earth.
That's what the government wants you to think.
He was just joking around, and I totally thought he was joking, but he wasn't joking. He actually believes that the Earth is flat.
That is unfortunate.
We're not friends anymore. Ooh.
Well,
I dropped him. Ooh.
okay. I would say you don't need to maybe,
Yeah, we just.
that seems harsh, but
We're so friends, but we just don't talk.
okay. So moving on to our mineral stuff. So the difference first between rocks and minerals. So this right here, this is granite. Granite is a rock.
Whoa.
All rocks are made up of different minerals.
Atoms.
Okay, rocks are made up of minerals. Whereas minerals, so this is quartz, okay? Minerals are made up of the same stuff over and over and over again. One piece of granite can be really different than another piece of granite. It's going to have different amounts of different kinds of minerals in it, but minerals are going to be the same, they're constant. And so that's what kind of makes minerals unique. All right, so this granite is made up of 3 different types of minerals. It's made of quartz, and it's made of this stuff called mica, and also felspar is the other mineral. But we'll get into rocks later, second quarter. Here are the tests that we need to be able to do. Okay, so my expectation for my 8th graders is this. We need to be able to take a look at minerals and figure out what they are. That's kind of like our final step. Look at a mineral and figure out what it is. And so I'm going to teach you guys some tests that we can, what these minerals are. The first test that we can do is just the color. The color. So that first C right up on top is color. Here's the problem. Okay? And so the problem here with the color test is this. Does anybody know what this mineral right here is? It's kind of a greenish.
Emeralds.
It's called fluorite. Has anybody ever heard of fluorite before? Okay. This one right here. This is a nice purple one. It's not an amethyst. It's not an amethyst.
Those are like
Fluorite? What's that? This is fluorite as well.
Netherite.
Exactly. So this is fluorite and this is fluorite.
How's that?
What's the problem?
The one purple.
They're different colors. So here's what I want you to know. The color test can tell us some things, but it's unreliable. What is the color test?
Unreliable.
It's unreliable. So we say the same mineral can have a variety of colors. It is not reliable. Okay? So we just take a look at it, write down what color it is. Okay? It can help us, but it's not like the end all be all. Okay? So the next test that we can do is called the luster. The luster test. And the luster test is the way a mineral reflects light. How a mineral reflects light is the luster test. So what I'm going to do this test is I'm going to take a mineral and I'm just going to take a look at it and shine it in the light. And there are some specific things that I'm looking for. If we had more time and we were in like a high school or college geology class, we would put the luster of the mineral in a whole bunch of different categories. For us, for right now, we have a week and a half. We're going to do 2 categories. There's going to be metallic and non-metallic. That's all we're looking for. Metallic versus non-metallic. So, we're going to write those in. Metallic and non-metallic. Jen.
Is is acrylic like a mineral, or like, can it be in the form of a rock like acrylic?
Acrylic? I don't think so. I think acrylic is, in order for something to be a mineral, it can't be man-made. It has to be a naturally occurring thing. And I think acrylic things are usually man-made. What's that?
No.
Oh, sorry. Okay. So, how do I tell if something's metallic or not metallic? For me, I like to think about the Olympics. Okay? And so, I love the Olympics. We actually, in 1996, the Olympics were in Atlanta. That was one of the most recent times here. And my family got to go down and check them out, and it was awesome. So that was pretty awesome. So I like to think about the Olympics. Here's why. In order for us to figure out if something is metallic or not metallic, it's going to have one of the colors of one of the Olympic medals. So what are the colors of the Olympic medals?
Gold.
Gold,
Bronze.
silver, bronze. So if I'm trying to figure out if this is metallic or not metallic, it's going to have a shine or a sparkle, and that shine or sparkle is going to be gold, silver, or bronze. This one right here is kind of shiny, but it's pink. So I know that it's non-metallic. Okay, so metals always are going to be gold, silver, bronze. This is a good example of a metallic one. This is a nice shiny gold.
Fully.
Okay, fool's gold, yep. And then this is another example of a nice metallic one.
What's that one?
This one is called galena. This is like my favorite mineral. Pretty
Who
cool.
made the rock names?
This is the heavy one. That's just like this. What's that?
Who made the rock names?
Who made the rock names? I made them all. Jenna,
Do you have any gold?
79. Do I have what?
Any gold?
179. Do I have gold? Yes, I've got gold everywhere in here. But it's all
He's
hidden.
rich. He's
And
rich.
I'm rich.
It's like
So, all right. Luster. Make sense? Metallic, non-metallic. That's what we're looking for. We're going to practice this today. All right. The next one is called the streak. And the streak is actually a lot like the color, except the streak is reliable. Okay? And the streak test tells us the color of the mineral's powder. Okay? So how do we find the mineral's powder? What we do is we take the streak plate and we take the mineral and we just rub the mineral on the streak plate and a color comes off. And so we just take a look at it. In order for this to happen, which of these has to be harder in order for the powder to come off on the streak plate? The streak plate has to be harder. So if the mineral is harder than the streak plate, it won't work.
What's a street plate?
Just something to think about. It's made of porcelain.
Why is it made out of diamonds?
That's a great question. I'll bring in some diamond ones next week. Jenna,
Okay, like, can diamonds streak? Or like, is that not possible? Like, is it actually too?
so a diamond wouldn't leave a streak. Why wouldn't it leave a streak?
Because it's the hardest rock in the mineral.
Because it's the hardest mineral. So we're going to talk about diamonds here in a minute.
It's also clear.
But here's the deal. This mineral right here, this is that really shiny gold one. Okay? And so this is pyrite gold. It's really, really bright gold. And so I would expect its streak to be really, really bright gold too, right? But when I'm doing streak on here, sorry, what color is that? Kind of like a black, right? A blackish, it's kind of like a brownish, greenish black. That's what color this nice, shiny, bright gold leaves. Why we do the streak? Because this is really consistent. Pyrite always leaves the same color streak, even though it might look a little bit different. Okay, does that make sense? So, if a mineral like this, that's kind of more of a whitish color, or if it doesn't look like it's leaving a streak, I would always try to rub my finger on the streak plate and see if it leaves a color behind. Because then it'll leave, so that one was white. So, there's that. Questions on streak?
Are we doing this inside or outside?
I think we can go outside for this.
Let's go!
The next test, which is the last one that we're doing today. Okay, we're going to learn about all these, but this is the last one that we're doing today. The next one shows us how a mineral breaks. Okay, we're not actually going to break the minerals. We're going to assume that they've already been broken, but that's what this shows. So this is going to be, it's called cleavage or fracture. So the mineral is either going to have cleavage or fracture. Jenna, did you have a question?
I was just going to ask you.
If you could tell me what it was going to be.
Yeah.
Did you get it?
Yeah, so right under the beach.
So, cleavage and fracture. So, here's what it looks like, okay? If a mineral has cleavage, what it means is it breaks along flat, straight, smooth angles. Okay? When it breaks in flat lines. So, these are some examples of something that would be cleavage. If it looks like a square or a box, just like this one. Okay? If it looks like that, right? It's got some nice straight lines here. And then sometimes minerals kind of form in sheets like this. Anytime we have sheets, that would be an example of cleavage as well. Okay? Fracture would be if it doesn't have any patterns for how it breaks. If it breaks unevenly, jagged, or round, okay? Those would be examples of fracture. So we're looking at how the mineral breaks, and we're assuming that it's already been broken. Questions there? Okay, so these is cleavage versus fracture. You might need to look closely for that one. The next part is the hardness. The hardness of a mineral is not how difficult it is to break a mineral. It's how difficult it is to scratch a mineral. Okay? And so that's the resistance of a mineral to be scratched. So what did we say was the hardest mineral?
Diamond.
A diamond. Diamond's the hardest mineral, which means a diamond's not the hardest mineral to break. It's the hardest mineral to scratch. And that's kind of why diamonds are so valuable, is because they don't get scratched, they don't get worn out. Okay, it's really, really difficult for anything to scratch it. You can only scratch a diamond with another diamond.
What if a tiger scratches it?
What's that?
What if a tiger scratches
A
it?
tiger?
Yeah.
Then the tiger wouldn't do anything.
What?
Right, because it's too hard. Isn't that crazy? Diamond wins, tiger loses. Eli, Jenna, question.
So then how do wedding rings like my sister's wedding ring was like she always gets it recolored or like in diamond and
Yeah.
she always gets it like
Clean.
clean. So like how is it dirty?
Usually the band, or there's stuff that gets on the outside of it, dirt and oil and grease and things like that. And so then they have to find ways to get in there to clean it, to make it shine, because diamonds have they have a lot of different facets. That's the faces of it. And so when the light can get through all the facets, then it's really nice and sparkly. So, why?
If it's the hardest mineral to scratch, and not like to break, what's the hardest mineral to break?
What's the hardest mineral to break? I'm not really sure. The one thing about some of the minerals, so metals are really difficult to break, because instead of breaking, what do?
And then
They bend. So it's kind of like, well, metals have a property that they're called malleable, meaning they bend instead of breaking. So probably a metal. Jenna,
the diamond ever been broken?
has a diamond ever been broken? Yeah, it's actually, diamonds aren't that hard to break. So if you take a diamond and you kind of hit it right with a hammer or something like that, they can shatter. But they're really hard to scratch. So that's why they're really up here on the hardness
I
scale.
saw
Yeah.
Jimmy Perfect hit a diamond with a hammer and it did not break.
It didn't.
It broke the anvil it was on.
Did it really?
It dented it.
Crazy.
So you're lying.
Okay. All right. Dude Perfect wins. To do the hardness test, here's what we do. We know the hardness of 4 fairly common objects that we have in here, so we're going to use those things to figure out, okay, is this mineral harder or softer than these objects? And then we'll place them in different groups, okay? So we always start with our fingernail, okay? So if I've got this rose quartz, okay, and I'm going to try to first scratch it with my fingernail. My fingernail does not scratch this. So which is harder, the mineral or my fingernail? The mineral's harder. So I know that it has a hardness of more than 2.5 because my fingernail has a hardness of 2.5. So then I would move on to copper. Copper has a hardness of 3.5. So I'm going to try to scratch the copper with the mineral. If the mineral scratches the copper, which is harder?
Obviously, mineral.
The mineral is harder. So I'm going to keep going. Now I know it's higher than 3.5. I'm going to move on to glass. Glass has a hardness of 5.5. I'm going to try to put a scratch in this glass. If it scratches the glass, which is harder?
The mineral.
The mineral. So I'm going to move on. And my last one is a street plate, that porcelain. Porcelain has a hardness of 6.5. I'm going to see if this will dig into or scratch the porcelain. Okay, so you have to look carefully. If it scratches the porcelain, that means it has a hardness of higher than 6.5. So we're going to just go through those tests. That one is pretty involved, so we're going to save that for Tuesday when we're here to do that in class together. Okay, the last test that we do is we can check the density, how tightly packed together it is. Okay, and so that's always going to be the same. So we could weigh it to find the mass, put it in water to find the volume, and then divide those, and that'll give us our density. Some of the other things that minerals do, some minerals have a property of fluorescence, meaning if you shine a black light on them, they'll glow, which is kind of cool. So I'm going to see if I can bring in a black light next week so we can take a look at some. What?
Did you know scorpions glow?
They do. Pretty
There's
cool.
like clear scorpions and clear frogs.
And clear frogs.
So if you shine a black light into the sand, you can see where scorpions are.
Yeah. And that's when scorpions, and at night, that's when scorpions come out. So that's when you'll be able to see them. Some of the minerals, if you put acid on them, they'll fizz. They'll have a chemical reaction to acid. So there's another unique property. Some do some crazy stuff with light. Some of them are magnetic, okay? And some of them have a salty taste. Like this right here. This one
Let me taste.
Lick
tastes
it,
really
lick
salty.
it.
Because what do you think this is?
Salt lead.
Salt.
It's salt, okay? It's called halite. Halite is the mineral name for salt, all right? And so all this is salt. We're going to be testing salt out there when we go out to test them, okay? Just a heads up, if you're tempted to lick it,
Don't lick it.
Don't COVID-19.
just know that other people probably have before you, and it might not be a great idea. So there's that.
All lick
Yeah.
it.
You can decide what you want to do with that. Questions on our mineral tests? Jenna?